Good morning. I am Tushar, student of BSc Chemistry on our third year. Today I am here to give a presentation on the topic called the phase diagram of water system. First we will make our diagram, then I will explain it. On the x-axis we will take temperature, on the y-axis we will take pressure, and we will draw the phase diagram for a water system. We know it is only one component system because H2O is the only compound involved in it. So first we will start with the curve OA. OA is the vapor pressure curve as it gives vapor pressure of H2O at different temperatures. We can see it is a equilibrium between vapors and a liquid. It starts with at the point O, and the point O is called the freezing point of the water, and ends at the point A. A is called the critical temperature of water because beyond this temperature only the two phases, that is liquid and vapor, merge together, and the critical temperature for water system is 374 degrees Celsius. Now we will calculate the degree of freedom for this. Now for curve OA we will calculate the degree of freedom. Degree of freedom for curve OA. For this we will use the phase rule, which states that the degree of freedom of a system is equals to the components minus the number of phase in the system plus 2. Now in the curve OA, degree of freedom is equals to the components. As we know, this is a one component system, so this value of C is 1 minus OA is a phase equilibrium between vapors and liquid, so the total phases present on the curve OA are 2 plus 2 is equals to 1. So when we solve it, we get the degree of freedom 1, which means it is univariant. Univariant means that at a fixed temperature value, there is a fixed value of pressure. Now moving towards the second curve, that is curve OB, which is the sublimation curve. As here, solid, ice and vapors exist in equilibrium. It gives the vapor pressure of ice at various temperature. Thus, we can just say it like vapor pressure curve of ice. Now it starts with the point O, which we have discussed earlier as a freezing point, and ends at the point B. Here point B is called the absolute zero, or we can say 0 Kelvin, and if it change it in the Celsius, then it will be minus 273 degrees Celsius. So beyond this temperature only solid form exists. Vapor phase does not exist beyond this temperature. Thus we can say at this point, beyond this point, solid form and the vapor form merge together. Now we will calculate the degree of freedom for this curve as well. Now similarly for curve OB, we will calculate the degree of freedom. Same, we will use the phase rule here as well, that is degree of freedom is equals to component minus number of phase plus 2. So here we know it is sublimation curve, as it has vapors and ice in equilibrium, so there are number of phases here are 2. So degree of freedom is equals to component system is 1 only, and phases are 2 plus 2 is equals to 1. It is also univariant, means here also particular point has a particular value of temperature, and we can say in other words that at a particular temperature, or we can say at a fixed value of temperature, we have a fixed value of pressure, or vice versa. Now moving toward our last curve, that is curve OC. It is called the fusion curve of ice, as it shows effect of the pressure on the melting point of the ice. Here we can see that O and C points are there, and there is an inclination towards the pressure axis. This represents that the melting point of ice decreases upon increasing the pressure. And for this also we will calculate the degree of freedom. Now for curve OC. For the curve OC, we have degree of freedom, as OC is a curve, that is fusion curve between solid or ice form of water and the liquid form of water. It is an equilibrium between them. So there are total 2 phases here. So degree of freedom, we will use the phase rule here as well. So number of components is 1 minus total number of phases are 2 plus 2, which gives it's 1. So it is univariant. So here also we can say for any given pressure there is a fixed value of melting point. As in the diagram we can see the OB curve, OC curve and OA curve meet at a we can say the same point, which is called the point O. So all these curves point here only, so we will call it a triple point, because here the solid form, the liquid form and the vapor form of the water coexist in the equilibrium with each other. Now we will calculate the degree of freedom for this point O. Now we will calculate the degree of freedom for the point O. That is, we can say at triple point. So we will use the same formula, that is phase rule for point O. So degree of freedom is equals to components minus number of phases plus 2. Component is 1. Now here we have understand that vapors, solid and liquid coexist in the equilibrium. So at this point there are total 3 phases existing together. So the number of phases will be 3 plus 2, 2 plus 1, 3 minus 3, 0. This means here degree of freedom is 0, or we can say it is non-variant. What does non-variant means is that there is a fixed value of pressure and temperature, or we can say 3 phases coexist in equilibrium at a definite value of pressure and temperature. And for the water system, the temperature is for this point is 0.0075 degree Celsius and the value of pressure is 4.58 mm. Now we will discuss the area AOB, AOC and BOC. In the area AOC, only liquid form exists. In area AOB, only vapor phase exists, and in area BOC, only solid form exists. And now we will calculate the degree of freedom for this point for the areas as well, for AOB, AOC, and BOC. Now moving toward the areas AOB, BOC, and AOC. So these contains that we have already discussed that AOB contains vapors only, AOC area has liquid only, and BOC area has solid only. So there are only one phases in each of the areas. So degree of freedom for area AOB, AOC, and BOC. F is equals to, using phase rule here again, the components is one only, that is H2O, minus phase is also one because at AOB it is vapor, at AOC it is liquid, at BOC it is solid. So phase is also 1 plus 2. So here degree of freedom is 2, which means it is bivariant. Now what does this bivariant means? It means to locate a point, whether in this or in this area or whether in this area, we need a definite value of temperature and pressure. What does this means? This means that here we can see, like at this temperature there is a value of pressure. Let's suppose it is 3 point something, and at this same temperature, if we move a little up here, we have another value of pressure. So we can't express, or we cannot locate a point without the fixed value of temperature and pressure. This was the phase diagram of water system. Thank you.